Good morning there, ESIP. It's the wee hours of the morning here, and I'm up early because I got to make an exciting video today to share some of the fun stuff I've been working on. But had a little bit of a rough start to the day. I got up and had a totally dead battery. Solar wasn't charging yesterday because it's been raining up here. Um, Up in the mountains, kind of working from up here, getting out of the heat of the city, and enjoying some time with a bear that came through the camp last night. Some other things kept me up all night, but anyway, doing pretty well. And I'll talk to you here in just a little bit, share some of the stuff I'm working on. Cheers.
In USGS, like a lot of institutions, we're constantly asking ourselves, because we're being asked by Congress and other stakeholders, what capacity do we have to do this or that kind of research or inform this or that type of stakeholder decision? Right now, it's stuff like, what can we contribute to a national conservation atlas to help track progress toward conserving 30% of lands and waters by 2030? Or what do we need to do to thoroughly examine abandoned mines for critical minerals potential and assess how those activities will impact other resources? These questions always mean we need to have a handle on the state of science, the state of our workforce, the state of available cyber infrastructure, and a bunch of other stuff. Being able to ask and answer these questions thoroughly, accurately, and quickly has been like the white whale to our Captain Ahab. Every director that's led the USGS since I came here in 2004 has wanted some kind of Uber dashboard that they can answer all these questions at the push of a button. Instead, we send out dozens of dreaded data calls every year, collecting the same information in a bunch of ways that somehow never makes it into anything lasting. We have tried to build data systems of various kinds, but they've all fallen under their own weight. In the last while, I've set about trying to pursue this elusive problem by taking a slightly different tact and exploring my own research interests in linked open data and knowledge graphs. I codenamed this work ISED for the Integrated Science Assessment Information Database, and it really all comes down to building a graph out of the whole of USGS. I started off with a picture like this in my head of how all the information we already have and are trying to manage in better ways should all connect and be part of answering research capacity and planning questions. I set about trying to make this real by probing at every catalog and information system where information on these things shows up. For years, I've wanted to have an institutional graph like this connect to a larger scientific knowledge graph, like what Peter Fox and many others helped to build behind the National Climate Assessments. Articulating and connecting all the dots to scientific findings and their impact on public policy is the really exciting part. What if we could be systematic in how we build those knowledge graphs in different domains by having every scientific institution be responsible for serving its own wares in a way that stubs right into these larger graphs? So nominally, all the nodes in this graph should relate to everything else in all these ways. Our metadata about publications and data sets references people and organizations and topics and other stuff. We sort of start to use persistent, resolvable identifiers like DOIs and ORCIDs and IGSNs, but when you apply strict rules of engagement with the information morass by forcing yourself to only use software codes to do all the work, that notion pretty quickly falls apart. The clues are there, but it still takes a crapload of work to put all the pieces in place. One of my ulterior motives in this work is to show all the owners of the various information systems and processes USGS has that cover little sectors of the big picture just how awesome they could be if they started ascribing to the basics of linked open data. Examine everything in your bit of the information pool to identify what all you can link to, confirm and make those links explicit, and then advertise your stuff so people and algorithms can use it. I've got a work in progress Python package called PyLinked CMD where I'm building out modules that essentially do the work of dealing with just how messy everything is. In there, there's a marked difference in the level of complexity needed to do things like consulting DOI and ORCID registries that are technically robust versus the massive amount of code needed to scrape websites for vital information that's really available nowhere else. If there were only some kind of module that implemented schema.org linked data in web pages. A lot of the data I needed to deal with and bring together is so messy that we set up an intermediary caching mechanism that uses the PyLinked CMD code to run Lambda processes in the cloud to constantly pull and bring everything together for use. With most of the logistical access figured out, I set about making reality out of the graph in my head by building a real graph in Neo4j. All the logic needed to apply rules and constraints on the data is laid out in a series of data building and graph populating Jupyter notebooks included with the PyLinked CMD package. As I get things worked out in practice, I'm feeding better code into the processing modules themselves so we can eventually run the rest of it live somewhere. As logical as I think graph databases are, they do seem to be a bit much to hand off to the average non geek for consumption. So I've also fiddled with a much more boiled down faceted entity search whose facets are driven by the graph. A USGS researcher's profile page might not list all the things they work on by name, but if we can get through to their publications, datasets, and models and the subject matters they deal with, we can bring all that into focus. The fun stuff I'm working on now is using a combination of rule based and machine learning methods to turn undefined subject matters into defined subject matters, those that link to a usable source of definition, context, and expansion into other linked concepts. Given the big blobs of text that I assemble from some source material, I'm starting to train knowledge graph based entity linking models to get the best characterization of everything in the graph. Iterating on real world capacity exploration questions, like I mentioned earlier, points out new sources of definition and semantics that I need to go after in my ever expanding reference terminology library. I'm pretty confident that I'll have this thing wrapped up in the next few months. I'll clean and polish and release the software package for our own production use and others to think about. I'll have the rest of the continuous process in place to apply all the constraints and build a live graph from confirmed relationships. I'll have continuously operating NLP processes for the texty parts that yield useful characteristics, and I'll publish some sort of advertisement of the work. The lesson, I hope, will take hold in USGS really is the simple, elegant concept of linked open data as Berners-Lee laid it out in the 5-Star Challenge. Enough tooling and proven methodology has been developed in the last number of years, including much of that here in ESIP, that we really all should be able to dive into the important parts down at the content level. And part of my work is pointing out those real issues we need to deal with. For instance, within the 21,000 records of datasets in the current USGS public data catalog, data documenters have asserted over 5,000 unique terms as being sourced in the USGS thesaurus, our best corporate controlled vocabulary source specific to our work. That can't be right. There are only 1,159 total terms in the USGS thesaurus. When we actually dig into the terms and check against the thesaurus with just a little bit of room for spelling error, we come up with 721 matching terms. But that's actually pretty good. It's not a bad metric to say we have data sets that can be characterized with terms that cover more than 60% of the major subject areas that USGS deals with. But let's get into the fun work of checking the assertions we've thrown around for years, make sure the linkages and relationships are explicit and verifiable, and then assess where we need to do more work.